All right, guys, so what's really cool is that we are actually going to get exposure to not just compositions of 2 functions, but here for the first time, the composition of 3 functions. And so what we do is call this the extended chain rule for derivatives. And what you'll notice is that the composition is just much meatier than the one that we saw before. We actually have f of g of h of x here. So the innermost function is called h. That's composed into g, and that composition itself is then composed again into f. To find the derivative of something like that, we're going to start on the inside, start on the outside, the outermost function, and work our way into that innermost piece. So just like before, we're going to start with the derivative of the outside, and that's going to be evaluated at the inner composition. Then we'll move on to the next piece. We'll find the derivative of the g function, the next outermost piece, evaluated at the inner piece at h, and then multiply that finally by the derivative of that inside. This is going to be a lot, and you'll notice down here in this first extension question, the function is just quite messier than anything you're used to. So if I utilize the names that are provided up here, what I'm going to do is try to identify my f, my g, and my h. And remember, for me, it's easier to start on the inside and try to identify the innermost function, which I hope you can see is that quadratic. The quadratic is composed inside of a square root, and the square root is composed inside of f of x. Convenient that those are the same here. Now I'll find f prime, g prime, and h prime, because these will be necessary to move forward through this process. H prime is 2x, g prime is 1 over 2 square roots of x, and f prime is just f prime. So when I go back to this original function, I'd like to find the derivative of this mega composition. I'll start with the outer function. That's the f prime that needs to be evaluated at g of h of x, which is our square root of x squared plus 1. I'm going to multiply that now, so I've kind of like done this part. I need to now think about the g prime. That's 1 over 2 square roots of x, but here it's not an x, it's an h of x. There's my x squared plus 1 showing up, taking care of this, and all I need to do is multiply now by h prime, 2x. The nice thing here now is that I need to evaluate this at 0. So this becomes f prime of the square root of 0 squared plus 1 times 1 over 2 square roots of 0 squared plus 1 times 2 times 0. This is f prime of 1 times 1 over 2 times 0. And I know without a doubt that when I multiply those things by 0, I'm going to get 0. I would like to remind you that I could find the derivative of 1 by utilizing the slope on this graph. Slope looks like -1/2 if I just do some rising and running. But again, that's not super important because I'm multiplying all that by 0. And there's my answer. There's that chain rule of several compositions inside of one another.